Okay, we are recording. All right. Hi, everyone. So today, let me share screen. Yeah. So if you go to our course webpage, oops, you guys are seeing behind the curtain. You go to our course webpage, and we have like the class meeting pages. So I'm trying to update them a little bit. But there's the handout for today, and then I'm gonna put you into breakout rooms. I have that gather 2D space, but and that's a fun place to do group work, except that it has the free tier has a limit of 25 simultaneous users. So sadly, we can't. There's 31 students in the class, so we can't use that today for group work. But I'll just put you in breakout rooms, and there's a Jamboard, which is basically just blank pages labeled for each breakout room, and so you can. And actually, I'll just show you. If you click on the link, right now it's just like page 1 is breakout room 1, page 2 is breakout room 2, and so on. So like once you're in a breakout room, you can go to this page at this link and start writing there. You can open the link on your iPad too and write on it. In fact, I have it, yeah, that's me writing right there on my iPad. Oops, something went wrong. And it reloaded, but that was weird. There's a Jamboard app actually on, except my Jamboard app is freaking out, so never mind. Anyways, okay, so yeah, but briefly we'll talk about some stuff from this handout. So you might want to pull this handout up through the web page, or I could even put the link in the Zoom chat. Actually, it's probably just a good thing to do. It's the easiest for everyone. Yeah, so there's the handout we'll be working on, and I'll put the Jamboard link in a little bit when we are going to break into breakout rooms. And I won't record. Once we get to go to breakout rooms, I'm going to stop the recording also, so don't worry about, I don't even know how recording works at breakout rooms, but don't worry about being recorded there. In fact, let me go, actually, I'm going to share my iPad screen. Just always a bit, see if this works. Okay, so this is the handout. And I kind of just want to talk, basically, I think I kind of took you through this progression Monday when I was talking about sort of the overview of the class, right? And the progression is that we sort of have to almost start over and go through all of math again, from like, the Cartesian plane to like pre-calculus to like differential calculus to integral calculus. So we're back at the when you started doing stuff with the XY plane, but now we're going to do XYZ space. So we just have to get used to that a little bit. And that's only going to take up today's class. We'll go right into doing functions with 2 variables, maybe by the end of today, or at least definitely by Friday. So, and I talked about this a little bit. So what we're going to do is we're just going to look at the first three sort of things here, problems with like items on this handout together. And then we'll, from number 4 on, I'll just have you guys work in groups, and I'll jump around and visit each room. So, like I said, this is sort of our idea of the, X, Y, Z, the way we tend to draw the 3 axes. I put these are supposed to be like perpendicular signs to indicate that they're all perpendicular to each other. And, in some ways you should think of the x-axis as pointing straight at your eyeball, but then since we can't really, then we wouldn't be able to see it. We sort of draw it down here, or just imagine that we're looking from sort of like inside a room at the corner of a room, right? And then the thing I'll notice is like, why did we put x here and y here instead of the other way around? Because you can sort of tell that if we did that, if we do this, if you sort of if you think of looking down from above, like if you put your eyeball on the z-axis and look down, then you'll actually see the sort of standard X and Y, like the way we're used to having them oriented, right? As opposed to if we swapped X and Y, it would be wrong. We would have Y here and X here. So that's kind of one reason we're doing it. If that makes sense. And then it says, and then I said here, like, we could have had the Z-axis point down or something like that instead of up. I mean, there's not, that's sort of a little bit of an interesting question, like, why does it go this way? I mean, I guess we could have had Y and X switched if we had Z going down or something, but there's a reason, and it's just a convention. It's just a convention of how we orient space. And it's called the right-hand rule. And I said, like, remind me to discuss it. So reminding myself to discuss it. The idea is, maybe I should just write it. I'm just going to try to write on this so we can just see. So there's this right-hand rule, which is you point your fingers along the X, point your fingers, not your thumb, just your like four fingers. Point fingers towards the X-axis or along the X-axis. Like imagine, I guess you should imagine your hands at the origin, right? Maybe I should say that first. Oops. Yeah, so imagine your hands at the origin. Which, if I haven't made that clear, is this is like 0, 0, 0 right here. And point your fingers towards along the X-axis. Maybe I would use the word along. And then curl them towards the Y-axis. Right, so can you imagine that you're like pointing your fingers along the X-axis, curling them, put my hand up to the screen, curling them along towards the Y-axis. And so you have to orient your palm a certain way to do that. And then if your thumb is sticking out, that's pointing in the direction of the Z-axis, right? So then the thumb, stick out your thumb. I don't know, writing this in words, which makes it all sound silly, but this points in the positive Z direction. Does that make sense? Point your fingers towards X, turn your palm so that you can curl towards the Y-axis, right? If the Y-axis is on the other side, I'd have to turn my hand upside down to curl, right? If I wanted to curl the other way. And then whichever way you're curling, then it's your thumb points in the direction of the Z-axis. And this right-hand rule comes up a lot in physics. It'll come up this semester in terms of like the cross product of vectors and other things we're going to talk about. So it's worth it's sort of worth mentioning now. Any questions about that? Does it make sense what I'm trying to do? Yes, kind of. Okay. So that's the convention, but that's kind of, we always use these right-hand rule conventions. All right. Now, what about labeling points? So I just think getting used to thinking about where points would live. So this number 2. So like, where does the point 1, 0, 0 live? If we're thinking about, I mean, I guess I should say we're thinking about these as like X, Y, Z, right? So where does 1, 0, 0 live?
On the X-axis.
On the X-axis. So whatever 1 unit is. So like, so maybe right there is like 1 unit. So maybe that's 1, 0, 0. And I think I asked about 0, 1, 0 and 0, 0, 1, right? So 0, 0, 1 would be about the same distance. I'm sorry, 0, 1, 0 would be about the same distance that way. And 0, 0, 1. I have no idea if I'm picking the same distances. Okay. 0, 0, 1 would be about there, right? And then what about negative 1, 0, 1? Well, I knew this was going to be in the wrong. It's over here. So if we do negative 1, 0, 1, I guess one way you can think about that is we want to go negative 1 in the x direction. So it's kind of like this would be traveling like negative 1 in the x direction, 0 in the y direction, and then 1 in the z direction. Probably did too much there. Yeah, so, you know, we sort of have this too, right? So there's some sort of thing like that. And so that's one way to sort of think about it. I mean, it's a little bit hard to say like exactly, but if you're sort of following axes, you can think of this as like negative 1, 0, 1. Fair? Or you could do, before I do that last example, minus 3, minus 2, minus 2, you could think about something like negative 1, 1, 1, maybe. This out of the way a little bit. And use a different color. So like if we had negative 1, 1, 1, so then it would go 1 in the y direction and then 1 in the z direction. So you can sort of use these like sort of parallel lines to like to try to draw for yourself where things live, if that makes any sense. Right, like because anything parallel to the x-axis is like anything kind of in this direction. So these lines are like along the x-axis, and then this is in the y direction, that's in the y direction, and then that's in the y direction, and then these are in the z direction. Yeah, so you can sort of locate points that way. But the issue then is that like if I didn't have these sort of guide rails, it'd be hard to tell like where this point actually lived. Like maybe this point's closer to our face or something, right? So it's maybe actually in the like x, y, and z are all positive or something. And that was, I think, with minus 3, minus 2, minus 2. Well, if I try to go minus 3 in this direction, let's see, minus 3 in this direction, minus 2 in this direction, and then minus 2 in this direction. I think actually, I think I had an idea like this, minus 3 in this direction, minus 2 in this direction, minus 2 in this direction. Then it might actually be like behind the origin from where we're looking at. So then it's hard to, the point is it's hard to tell where specific points are in space, right? Like just from it, because we're looking at a 2D projection of 3D space, then you have these ambiguities. If I just draw a point like this, it's like, does this live, is X, Y, and Z positive, or are X, Y, and Z all negative, and this is much farther away or something, right? Again, please ask questions if you have them. But there's just some getting used to that, but it's not a huge deal. And then I thought we should talk through number 3, just because we're not in the classroom. Actually, normally I would do this in the classroom and be pointing at the walls and stuff. But I guess what's fair to say is that like this right here, and I think I drew this maybe even in class last time, is that like this floor here is the XY plane. I mean, it goes infinitely, but that's kind of the XY plane, right? And then that's called the XY plane because it contains the X and Y axes. And so as you can imagine, something like this, if you can see that, is the YZ plane. Oh my God, that's almost impossible to see. Sorry. Let me do a different color of that. Trying to use colors I haven't used. Maybe red. So this right here is like this is the XZ plane, right? So if you're in a classroom, that would be like the wall off to the side. And then the YZ plane is kind of the plane of the paper or the blackboard. And so we refer to those are just standard things we refer to. XZ plane, XY plane, XZ plane, YZ plane. And we'll talk a lot about things being parallel to one of those planes. So if we want to sort of orient ourselves, like, are we in a plane parallel to the XY plane? We're in a horizontal plane. Or if we're in a plane parallel to the XZ plane, then we're in like a vertical plane, but it's like the y-axis is perpendicular to that plane, you know? Stuff like that we're going to be talking about. Okay. And then I think from number 4 on, I'm just going to let you guys work in groups and go around and visit you. And just have you try to answer these questions and just talk them out. And you can write on the Jamboard too, like for your groupies. So once you, let me actually do that. Let me stop the share. Let me put the Jamboard link in the chat. A second to do that. I think, yeah, I made it everyone have edit privileges, so you can open this and start writing on it. So there's the Jamboard link if you haven't opened it already. And so I'm going to put you into Zoom rooms, and then we're not going to do, I mean, we might do this again a little bit on Friday, but I'm just going to just kind of randomly assign you to Zoom rooms if that's cool. Or breakout rooms. I always call them Zoom rooms. And so wait, let me see. There's 31 people, so maybe eight rooms. I made 8 pages on the Jamboard. Okay, I've created 8 breakout rooms. So I'm going to open them, and you guys can go there. But again, if there's any questions or anything before we do that, please ask. And if not, I will open the rooms and come visit you guys. So feel free, yeah, please go to your breakout room. So you're in room 7. Oh man, you know what? I forgot to stop the recording. I wonder what happened. I can actually I don't know what happened when the recording when we were in breakout rooms, but I cannot chop it out of the recording. So I'll have to do that later. I meant to pause the recording when we went to breakout rooms and start it again now. Okay, so yeah, I saw a lot of really good work. And so I think you guys definitely kind of are on top of this. Let me share screen again and go back to the handout. Open my iPad quickly. Okay, so yeah, so one thing that I didn't say that explicitly was like, or that some groups, weren't sure about, was like this whole, what's the equation of the XY plane? And an equation for an object is just it's an equation that everything in that object has to satisfy. And so what you saw like for the XY plane is that Z has to equal 0. So that actually is the equation of the XY plane. So, and similarly, the XZ plane is given by the Y equals 0. The YZ plane is given by X equals 0. For something like the X-axis, Y-axis, Z-axis, it's actually has to satisfy both, like for the Y-axis, both X has to equal 0 and Z has to equal 0. There's not like an equation, just one equation for it. You can think of it as two equations, I guess. But that'll be an interesting thing, that like surfaces are given by one equation, but curves in 3D, sometimes like they're harder to describe, almost like curves or lines in 3D. We're going to talk about that. There's like a parametric approach that you can use. But yeah, we'll get more into that. Let me just look here. Yeah, so everyone pretty much got the distance formula stuff. I just like that you've probably seen the distance formula before, but I like that you can actually really do it by just applying the Pythagorean theorem twice. And as most of you I saw were drawing the correct triangles pulling out of this picture. Right, so the general formula, as most of you saw, was like, you just take the differences in each coordinate and square them and add and take the square root. Okay, right. And then the sphere is all points that are 5 units from the origin. So you can think about taking the distance formula, here, plugging in 0, 0, 0 for this point and X, Y, Z for this point and setting that equal to 5. So you get just square root of X squared plus Y squared plus Z squared equals 5, or if you square both sides, you get that, right? And then I'm just going through this quickly to just make sure we're all on the same page. And then in general, right, you can, if you want to find the distance, the distance from a point to a plane is kind of a weird idea in general, but like, if you think of it as like the closest point, then it's not too hard. And I think the big thing though is, so for example, the distance from this point to the YZ plane was 3, right? So when you generalize down here, the distance from XYZ to the YZ plane is not just X, it's actually absolute value of X, because you want distances always to be non-negative. But like you can't just take the X value, because that could be negative, but it's the absolute value of X. Okay, great. So what we'll do Friday is we'll start jumping into functions and how to visualize functions of 2 variables. So like start looking at surfaces and stuff. And somebody asked, I do have office hours right after this. I'm actually going to hop over to the Gather link, which I think I showed you briefly on Monday, just because since I have students from different classes, it's easier to do in Gather and it's kind of more fun. So, but all good work. No, I went around and you guys all seem to be working really well. And so that was exciting. So good work today, and I will see you all Friday.
Thank you.
Thank you.
Thank you.
Have a good one.
Thank you.